Hello everyone, today we'll study graphs of trigonometric functions. First of all, let me show you the graph of sine and cosine. In order to graph sine and cosine functions, let's first of all complete the following tables. First table is about x and y equal to sine of x. Second table is about x and y equal to cosine of x. Let's complete the first table first. When x is 0 degree, what's sine of 0 degree? In last class, we know that sine of 0 degree is 0. Sine of 90 degree is 1. Sine of 180 degree is 0. And sine of 270 degree is -1. That's what we know from last class. How about sine of 360? How about sine of 360? For sine 360, we can subtract this angle by 360 degree. 360 minus 360 is 0. For sine 360, its coterminal angle is 0 degree. And we know that sine of 0 is 0. So sine 360 is 0. Now let's find the missing value in the middle. Next, let's find the missing value in the middle. What's sine of 45 degree? Sine of 45 degree, that's another special value. We know that sine of 45 degree is 1 over radical 2. Next, how about sine of 135? Sine of 135 degree, for this angle, we need to use reference angle. For sine of 135, we need to use reference angle to find the value. We know that a 135 degree angle lies in quadrant 2. For angle in quadrant 2, its reference angle is 180 minus the angle itself. And we know that 135 degree belongs to quadrant 2. Sine function in quadrant 2. Sine function in quadrant 2 is positive. Sine function in quadrant 2 is positive. So that's positive sine of 45. For 135 degree angle, its reference angle is 45 degree angle. And sine function in quadrant 2 is positive. We know that sine 45 is 1 over radical 2. So sine of 135 is also 1 over radical 2. Next, how about sine of 225? How about sine of 225? We know that 225 degree angle lies in quadrant 3. For angle lies in quadrant 3, its reference angle is an angle itself minus 180, which is 45 degree. So sine of 225 is in a sense sine 45 degree. The only difference is the sign. The sign could be either positive or negative. That's the only difference. Their value is exactly the same. The only difference is their plus minus sign. And we know that sine function in quadrant 3, sine function in quadrant 3 is negative. So sine of 225 is negative sine 45. We know that sine 45 is 1 over radical 2. So we get negative 1 over radical 2 here for 225 degree. Next, for sine of 315 degree, we know that 315 degree angle lies in quadrant 4. And for angle lies in quadrant 4, its reference angle is 360 minus the angle itself, which is 45 degree. So that's the reference angle. So sine of 315 is the same as sine of 45. Their value is exactly the same. The only difference is the plus minus sign. Now what's the plus minus sign here? We know that 315 degree angle lies in quadrant 4. And sine function in quadrant 4 is negative. So that equal to negative sine 45 degree, which is 1 over radical 2. So we get negative 1 over radical 2 when the angle is 315 degree. That's the first table. Next, let's try to complete the second table. Y equal to cosine of x. When x is 0 degree, what's cosine of 0? From last class, we know that cosine 0 is a special value angle. Cosine of 0 degree is 1. Cosine of 90 degree is 0. Cosine of 180 degree is negative 1. And cosine of 270 degree is 0. How about cosine of 360? How about cosine of 360? For cosine of 360, try to find its coterminal angle first. 360 minus 360 is 0 degree. And we know that cosine of 0 degree is 1. So cosine of 360 is also 1. Next, let's find the missing value in the middle. How about cosine of 45 degree? Cosine of 45 degree is a special value. We know that cosine of 45 degree is 1 over radical 2. Cosine of 45 degree is 1 over radical 2. Next, let's try to find cosine of 135 degree. What's cosine of 135? For cosine of 135 degree angle, we must use its reference angle. 135 degree angle lies in quadrant 2. For angle lies in quadrant 2, its reference angle is always 180 minus the angle itself. 180 minus 135 is 45 degree. So that's the reference angle. Cosine 135 is the same as cosine 45. Their value is exactly the same. The only difference is in the plus or minus sign. Here, 135 degree angle lies in quadrant 2. And we know that cosine function in quadrant 2 is negative. So cosine of 135 is negative cosine 45. And we know that cosine 45 is 1 over radical 2, which means cosine of 135 degree angle is negative 1 over radical 2. Next, how about cosine of 225? How about cosine of 225 degree angle? For cosine 225 degree angle, we must use its reference angle. First of all, 225 degree angle lies in quadrant 3. For angle lies in quadrant 3, its reference angle is an angle itself minus 180 degree, which is 45 degree. So that's a reference angle, which means cosine 225 is the same as cosine 45. Their value is exactly the same. The only difference is the plus or minus sign. The only difference is the plus or minus sign. And we know that this angle 225 lies in quadrant 3. Cosine function in quadrant 3 is negative. That means cosine 225 degree is the same as negative cosine 45 degree. And we know that cosine 45 degree is 1 over radical 2. That means cosine 225 degree is negative 1 over radical 2. Next, how about cosine of 315? For cosine of 315, we do the same thing. We must use reference angle to find a value. For cosine of 315 degree angle, first of all, 315 degree angle lies in quadrant 4. For any angle lies in quadrant 4, its reference angle is 360 minus the angle itself. 360 minus 315 is 45 degrees. That's a reference angle, which means the value of 315 degrees is the same as cosine 45 degrees. The only difference is in the plus or minus sign. The only difference is the plus or minus sign. We know that 315 degree angle lies in quadrant 4, and cosine angle in quadrant 4 is positive, which means cosine 315 is the same as positive cosine 45 degrees. And we know that cosine 45 degrees is 1 over radical 2, which means cosine 15 degrees is the same as 1 over radical 2. Here we can print a table for sine and cosine functions. Next, we try to sketch a graph. Now, before I start sketching the graph, keep one idea in mind. When we try to sketch graph, for all x values, we must use radian measure. We cannot use degree measure to sketch graph. We must use radian measure. When we try to sketch graph, we must use radian measure for x value. For x, we must use radian measure instead of degree measure. Next, let's convert all these degrees to radian measure. Here, if we convert each degrees to radian individually, it may take too much time. Let's observe these degrees first. 0, 45, 90, 135, 180, 225. We can see that here. 0 plus 45 degrees is 45 degrees. 45 degrees plus 45 degrees is 90 degrees. And 90 degrees plus 45 degrees is 135 degrees. 135 degrees plus 45 is 180 degrees. And so on. So here we can see that by adding 45 degrees to the previous number, we can get the next number. How much is 45 degrees? If we convert 45 degrees to radian, take 45 degrees times pi over 180 degrees. That can be rewritten as 45 degrees times pi over 180 degrees. If we simplify, divide top and bottom by 45, we get pi over 4. So 45 degrees is the same as pi over 4. So 0 degree is 0 radian. Plus 45 degrees, that's pi over 4. Keep adding 45 degrees. Pi over 4 plus pi over 4 is 2 pi over 4. 2 pi over 4 plus pi over 4. Pi over 4 is 45 degrees. 2 pi over 4 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4 is 4 pi over 4. Keep adding 45 degrees. And 45 degrees is pi over 4. We get 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Keep adding 45 degrees. We convert all these numbers to radian measures. So that's a quick way. Now simplify. 2 pi over 4 can be reduced as pi over 2. 2 pi over 4 I can divide top and bottom by 2. I get pi over 2. 2 pi over 4 is the same as pi over 2. 4 pi over 4, I can cancel 4 from top and bottom, I get pi. 4 pi over 4 is pi. 6 pi over 4, I can divide top and bottom by 2. I get 3 pi over 2. And for 8 pi over 4, I can divide top and bottom by 4. I get 2 pi. 8 pi over 4 is the same as 2 pi. And the same thing for the second table. 0 degree is 0 radian. 45 degree is pi over 4. 90 degree is pi over 2. 135 degree is 3 pi over 4. 180 degree is pi. 225 degree is 5 pi over 4. 270 is 3 pi over 2. 315 is 7 pi over 4. And 360 is 2 pi. When we sketch graph, we must use radian measure for x. When we sketch graph for trigonometric functions, we must use radian measure for the x coordinate. We cannot use degree measure when we sketch graph. Next, let's graph sine and cosine function. Let me graph sine function first. Let me graph sine function first. Y equal to sine of x. Zero pi over 4 pi over 2 prime points 3 pi over 4 pi 5 pi over 4 3 pi over 2 7 pi over 4 and 2 pi. Let's plot the points. First point 0 0. S is 0, Y is 0 is here. Second point pi over 4 1 over radical 2. S is pi over 4, Y is 1 over radical 2. 1 over radical 2, if we use calculator, it's about 0.7. 1 over radical 2, if we use calculator, it's about 0.7. Assume 1 is here. 0.7, a little above 0.5, somewhere here. Let's just, it's here. That's the second point. The third point, when S is pi over 2, Y is 1. That's the third point. Next point, when S is 3 pi over 4, Y is 1 over radical 2. It's here. Next point, when S is pi, Y is 0. That's the next point. Connect these points using smooth curve. Connect these points using smooth curve. Connect these points using smooth curve. Let's continue. When S is 5 pi over 4, Y is negative 1 over radical 2. 1 over radical 2 is about 0.7. So when S is 5 pi over 4, Y is about negative 0.7. Assume negative 1 is here. That's negative 0.7. When S is 3 pi over 2, Y is negative 1. Negative 1 is here. When S is 7 pi over 4, Y is negative 1 over radical 2. That's about negative 0.7. Next point, when S is 2 pi, Y is 0. That's the last point. Then continue connect these points using smooth curves. That's the sine function. This is called the first period. This is called the first period of the sine function. If we plot more points, we can see that actually sine function repeats itself after 2 pi. The sine function repeats itself. If we plot more points, we can see that after 2 pi, sine function repeats itself. And before 2 pi, the graph looks exactly the same. If we plot more points, we can see that before 0, the graph looks like this. That's called the first period of the sine function. After 2 pi, it repeats itself. And before 2 pi, it's the same graph. If we plot more points, we can see that. So this is the sine function. This is sine function. Next, let me plot cosine function. Let me graph cosine function. For y equal to cosine of x, do the same thing. We plot points. For cosine function, x is 0, pi over 4, pi over 2, and so on. Let's plot x coordinate first. 0, pi over 4, pi over 2, 3 pi over 2, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Let's plot each points. First point is 0, 1. X is 0, y is 1. Assume 1 is here. First point is 0, 1. Second point is pi over 4, 1 over radical 2. 1 over radical 2 is about 0.7. Second point is here. Third point, pi over 2, 0. That's the third point. Next point, 3 pi over 4, negative 1 over radical 2. 1 over radical 2 is about 0.7, so you get negative 0.7. When x is 3 pi over 4, y is negative 0.7. Assume negative 1 is here. Negative 0.7 somewhere here. Next point, x is pi, y is negative 1. When x is pi, y is negative 1. That's next point. Next, 5 pi over 4, negative 1 over radical 2. When x is 5 pi over 4, y is negative 1 over radical 2. That's about negative 0.7. It's here. Next point, 3 pi over 2, 0. When x is 3 pi over 2, y is 0. Next point, 7 pi over 4, 1 over radical 2. 1 over radical 2 is about 0.7. So x is 7 pi over 4, y is about 0.7, somewhere here. Next point, when x is 2 pi, y is 1. Then connect these points using smooth curve. Connect these points using smooth curve. Connect these points using smooth curve. That's the first period of cosine. Let's call the first period from 0 to 2 pi. Let's call the first period of cosine function. If we plot more points, we can see that the graph eventually repeats itself after 2 pi. The graph repeats itself. After 2 pi, the graph repeats itself. So from 0 to 2 pi, let's call the first period of the cosine function. If we plot more points, we can see that before 0, we have exactly the same graph before 0. And after 2 pi, the graph repeats itself. So for sine and cosine function, from 0 to 2 pi, let's call the first period of the graph. From 0 to 2 pi, let's call the first period of the graph. Next, let me show you some properties of these two graphs. Let me show you some properties of the sine function and cosine functions. For both sine and cosine function, their domain is always the set of all real numbers from negative infinity to infinity. For both sine and cosine function, their domain is always the set of all real numbers from negative infinity to infinity. Their range, sine and cosine function always varies from negative 1 to 1. Both sine and cosine function always varies from negative 1 to 1. So their range is from negative 1 to 1. The set of all real numbers from negative 1 to 1, including the endpoint, including negative 1 and 1. For both sine and cosine function, their range is from negative 1 to 1. Both sine and cosine function varies from negative 1 to 1. Next, the period For both sine and cosine function, their period is 2 pi. That means the graph repeats itself every 2 pi. The graph repeats itself every 2 pi. From 0 to 2 pi, it looks like this. From 2 pi to 4 pi, it looks the same. And from 4 pi to 6 pi also looks the same. From 0 to 2 pi, it looks like this. From 2 pi to 4 pi, it looks the same. From 4 pi to 6 pi also looks the same. That's why its period is 2 pi. For both sine and cosine function, its period is 2 pi. Next, the amplitude of both functions is 1. The amplitude is 1. Amplitude is the distance from, is half of the distance from maximum to minimum. It's called amplitude. We know that the range is from -1 to 1. So that's the maximum, that's the minimum. Amplitude is the half of the distance, is the half of the distance from maximum to minimum. So that's the range. Half distance is from 0 to 1. That's the amplitude. Amplitude here is 1. Same thing for cosine. The distance from maximum to minimum is from -1 to 1. Half of the distance is from 0 to 1. So the amplitude is 1. For both sine and cosine function, amplitude is 1. Amplitude is the half of the distance from maximum to minimum. Distance from maximum to minimum is from -1 to 1. Half of the distance is from 0 to 1. And amplitude is the half of the distance from maximum to minimum, which is 1. So that's the property of sine and cosine function. Domain is from -infinity to infinity. Range is from -1 to 1. Period is 2 pi. Amplitude is 1. Amplitude is 1. That's the property of sine and cosine function. Next, let me show you how to graph tangent and cotangent functions. We know that tangent x can always be written as sine of x over cosine of x. And cotangent x can always be written as cosine x over sine x. Those are the trig identities. Those are the trig identities. Here I'll graph tangent and cotangent based on the graph of sine and cosine. Here I'll graph tangent and cotangent based on the graph of sine and cosine. We know that the graph of sine looks like this. The graph of sine looks like this. It starts from 0. Its first period is from 0 to 2 pi. The number in the middle is pi. That's the sine function in the first period. That's the sine function in the first period. And we know that the sine function repeats itself. From 0 to 2 pi looks like this. From 2 pi to 4 pi looks the same. From 2 pi to 4 pi looks exactly the same. What's in the middle is 3 pi. And before 0, the graph also looks the same. Before 0, the graph also looks the same. That's from 0 to -2 pi. In the middle here is -2 pi. That's the sine function. That's the sine function. And cosine function looks like this. Its first period is from 0 to 2 pi. Cosine function starts from 1. Cosine function starts from 1. That's its first period. What's in the middle is pi. Then the intersection here, between 0 and pi, the midpoint is pi over 2. And between pi and 2 pi, the midpoint is 3 pi over 2. That's the first period of cosine function. And we know that since that's the first period, cosine function repeats itself. From 2 pi to 4 pi, it looks exactly the same. The graph from 2 pi to 4 pi looks exactly the same. The graph from 2 pi to 4 pi looks exactly the same. What's in the middle is 3 pi. And the point between 2 pi and 3 pi is 5 pi over 4. Adding up, divide by 2. 2 pi plus 3 pi is 5 pi. In the middle is 5 pi over 2. Adding up, divide by 2. The point here between 3 pi and 4 pi is 7 pi over 4. 7 pi over 2. Adding up, divide by 2. That's the midpoint. Adding up, 3 pi plus 4 pi is 7 pi. So in the middle, I get 7 pi over 2. Adding up, divide by 2. The same thing. Before 0, the graph also looks the same. It also repeats itself before 0. So from 0 to negative 2 pi, the graph also looks the same. Exactly the same graph repeats itself from negative 2 pi to 0. The midpoint between negative 2 pi and 0 is negative pi. The midpoint between negative pi and 0 is negative pi over 2. Midpoint between negative 2 pi and negative pi is negative 3 pi over 2. Let me label the same thing in the sine function. The midpoint between 0 and pi is pi over 2. That's 3 pi over 2 here. That's 5 pi over 2. That's 7 pi over 2. That's negative pi over 2. That's negative 3 pi over 2. Now, let's graph tension based on sine over cosine. Next, let me graph tension based on sine over cosine. For function tension, at 0 here, let's use sine over cosine. At 0, sine is 0, cosine is 1. 0 divided by 1 is 0. At 0 here, use sine divided by cosine. Sine 0 is 0, cosine 0 is 1. 0 divided by 1 is 0. So tension at 0 is 0. Now at pi over 2, sine at pi over 2 is 1. Sine pi over 2 is 1. Cosine pi over 2 is 0. 1 over 0 is undefined. 1 divided by 0. Sine divided by cosine. 1 divided by 0 is undefined. If the denominator is 0, we have a vertical asymptote. If the numerator is not 0 and denominator is 0, we have a vertical asymptote. 1 divided by 0 is a vertical asymptote. At pi, cosine pi is 0. Sine pi is 0. Cosine pi is negative 1. Sine pi is 0. This point is 0 here. Cosine pi is negative 1. 0 divided by negative 1 is 0. So tension at pi is 0. Tension pi is 0. at 3 pi over 2 at 3 pi over 2 here. Sine 3 pi over 2 is -1. Cosine 3 pi over 2 is 0. -1 divided by 0. If the denominator is 0, we have a vertical asymptote. When the numerator is not 0, denominator is 0, we have a vertical asymptote. So there's a vertical asymptote at 3 pi over 2. At 2 pi, sine 2 pi is 0. Cosine 2 pi is 1. At 2 pi here, sine 2 pi is 0. Cosine 2 pi is 1. 0 divided by 1. 0 divided by 1 is 0. At 5 pi over 2, sine 5 pi over 2 is 1. Sine 5 pi over 2 is 1. Cosine 5 pi over 2 is 0. 1 divided by 0. When the numerator is not 0, denominator is 0, we have a vertical asymptote. 1 divided by 0 is undefined. That's a vertical asymptote. So there's a vertical asymptote at 5 pi over 2. Before 0, at -2 pi over 2, sine -2 pi over 2 is -1. Cosine -2 pi over 2 is 0. -1 divided by 0 is undefined. That's a vertical asymptote. When the numerator is not 0, denominator is 0, we have a vertical asymptote. -1 divided by 0 is undefined. So that's a vertical asymptote at -2 pi over 2. At -2 pi here, sine -2 pi is 0. Sine -2 pi is 0. Cosine -2 pi is -1. 0 divided by -1 is 0. 0 divided by -1 is 0. Sine divided by cosine. Tangent is sine divided by cosine. 0 divided by -1 is 0. At -3 pi over 2, sine -3 pi over 2 is 1. Cosine -3 pi over 2 is 0. Sine -3 pi over 2 is 1. Cosine -3 pi over 2 is 0. 1 divided by 0 is undefined. That's a vertical asymptote. So those are the asymptotes and the intercepts. Next, let's try to sketch the graph in the middle. Look at the period here, between 0 and 2 pi. Between 0 and 2 pi, sine is positive. Cosine is also positive. When the curve is above x-axis, it's positive. When the curve is above x-axis, it's positive. So between 0 and 2 pi, both sine and cosine function, they are positive. Positive number divided by positive number is positive. If the curve is positive, and that's a vertical asymptote, that's an x-intercept, that's a vertical asymptote, the curve must be above x-axis. The curve in this period must be above x-axis, and it must get closer to the asymptote. So it looks like this. Since the x-intercept is 0, that's a vertical asymptote, and the curve is above x-axis, it looks like this. The curve must get closer to the asymptote. The curve must get closer to the asymptote. Now, from pi over 2 to pi, sine function is positive. From pi over 2 to pi, sine function is positive, but cosine function here is negative. The curve is below x-axis is negative. positive number divided by negative number is negative. So between pi over 2 to pi, tangent function is negative. That means that the graph is below the x-axis. The graph is below the x-axis. And that's the x-intercept. That's the vertical asymptote. The curve must get closer to the asymptote. That's the x-intercept. That's the vertical asymptote. The curve must get closer to the asymptote, and it must be below the x-axis. That's the curve between pi over 2 and pi. Next, between pi and 3 pi over 2, sine function is negative. Cosine function is also negative. Between pi and 3 pi over 2. Between pi and 3 pi over 2, both sine and cosine are negative. Negative number divided by negative number is positive. Double negative is positive. So from pi to 3 pi over 2, tangent is positive. And that's the vertical asymptote. That's an x-intercept. That's a vertical asymptote. The curve must get closer to the asymptote. And between 3 pi over 2 and 2 pi, sine function is negative. Cosine function is positive. Negative number over positive number is negative. So between 3 pi and 2 pi, tangent is negative. That's an x-intercept. That's the vertical asymptote. The curve is below x-axis. The curve is below x-axis, and it must get closer to the asymptote. It looks like this. Between 2 pi and 5 pi over 2, sine function is positive. Cosine function is also positive. Positive number divided by positive number is positive. That's an x-intercept. That's a vertical asymptote. The curve is above x-axis, and it must get closer to the asymptote. And on the other side, between 0 and negative pi over 2, sine function here is negative. Cosine function here is positive. Negative number over positive number is negative. That's the x-intercept. That's the vertical asymptote. The curve is below x-axis, and it must get closer to the asymptote. It looks like this. Then from negative pi over 2 to negative pi, sine function is negative. Cosine function is also negative. Double negative is positive. That's an x-intercept. That's the vertical asymptote. The curve must get closer to the asymptote. Next, from negative pi and 3 pi over 2, sine function is positive. Cosine function is negative. Positive number over negative number is negative. That's an x-intercept. That's a vertical asymptote. The curve is below x-axis. So it looks like this. That's the graph of tension. And the same graph repeats itself. The same graph repeats itself. From 5 pi over 2 to 7 pi over 2, the same graph repeats itself. There are infinitely many such pieces. The graph repeats itself. There are infinitely many such pieces. That's the tension. That's the tension function. That's the graph of the tension function. And for tension function, the domain for the tension function, the domain is all real number except these vertical asymptotes. The set of all real numbers except these vertical asymptotes. So for the domain, S could be all real numbers but s cannot be plus or minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on. S cannot be these numbers. S could be all real numbers except plus minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on. And the range is from negative infinity to infinity. The y value can go down to negative infinity and go out to infinity. The range is from negative infinity to infinity. The period of tangent function is pi. So from negative pi over 2 to pi over 2, that's one period. From pi over 2 to 3 pi over 2, that's another period. From 3 pi over 2 to 5 pi over 2, that's another period. So each period is pi. The gap here from 3 pi over 2 to 5 pi over 2, the gap here is pi. From pi over 2 to 3 pi over 2, the gap is pi. From negative pi over 2 to pi over 2, the gap here is pi. So the gap for each period is pi. We say the period of tangent function is pi. From negative pi over 2 to pi over 2, that's one period. From pi over 2 to 3 pi over 2, that's another period. From 3 pi over 2 to 5 pi over 2, that's another period. And the gap for each period is pi. The gap from 3 pi over 2 to 5 pi over 2 is pi. The gap from pi over 2 to 3 pi over 2 is also pi. The gap from negative pi over 2 to pi over 2 is pi. That's half of pi, that's another half of pi. Together is pi. The gap for each period is pi. That's the property of tangent function. That's a domain, range, and period. Next, let me show you how to graph cotangent function. The graph of cotangent is very similar. The graph of cotangent is very similar. We graph cotangent based on cosine over sine, based on these two graphs and this identity here. We use cosine divided by sine. At 0, cosine of 0 is 1, sine of 0 is 0. We use cosine divided by sine. 1 divided by 0 is undefined. That's a vertical asymptote. So at 0, that's a vertical asymptote at 0. At pi over 2, cosine pi over 2 is 0. Sine pi over 2 is 1. 0 divided by 1 is 0. Cosine pi over 2 is 0. Sine pi over 2 is 1. 0 divided by 1 is 0. So cotangent at pi over 2 is 0. How about pi? At pi here, cosine of pi is negative 1. Sine pi is 0. Negative 1 divided by 0 is undefined. Negative 1 divided by 0 is undefined. That's a vertical asymptote at pi. That's a vertical asymptote at pi. Next, at 3 pi over 2. At 3 pi over 2, cosine 3 pi over 2 is 0. Cosine 3 pi over 2 is 0. Sine 3 pi over 2 is negative 1. Use cosine divided by sine. 0 divided by negative 1 is 0. So cotangent at 3 pi over 2 is 0. How about 2 pi? At 2 pi, sine 2 pi is 0. Cosine 2 pi is 1. We use cosine divided by sine. Cotangent is cosine divided by sine. 1 divided by 0 is undefined. 1 divided by 0 is undefined. So that's a vertical asymptote at 2 pi. On the other side, at pi over 2 at negative pi over 2. At negative pi over 2. Sine negative pi over 2 is negative 1. Sine function at negative pi over 2 is negative 1. Cosine function at negative pi over 2 is 0. Negative 1 divided by 0. We use cosine divided by sine. 0 divided by negative 1 is 0. We use cosine divided by sine. 0 divided by negative 1 is 0. At negative pi, sine negative pi is 0. Cosine negative pi is negative 1. For quotation, we use cosine divided by sine. So, negative 1 divided by 0. Negative 1 divided by 0 is undefined. That's a vertical asymptote at negative pi. So those are the asymptotes. Next, let's sketch a graph based on the curve here. Between 0 and pi over 2. Between 0 and pi over 2. Both sine function and cosine function, they are positive. We use cosine divided by sine. Positive number divided by positive number is positive. That's an x-intercept. That's a vertical asymptote. And the curve is positive. That means it's above x-axis. Let's sketch a graph from 0 to pi over 2. It looks like this. That's the curve from 0 to pi over 2. Next, from pi over 2 to pi. From pi over 2 to pi, sine function is positive. Cosine function is negative. Cotangent is cosine divided by sine. So we use negative number divided by positive number is negative. From pi over 2 to pi, the function is cotangent is negative. That's the x-intercept. That's the vertical asymptote. And the curve is below x-axis. It looks like this. Next, from pi to 3 pi over 2. From pi to 3 pi over 2, sine function is negative. Cosine function is also negative. And cotangent is cosine divided by sine. Negative number divided by negative number, double negative is positive. So from pi to 3 pi over 2, cotangent is positive. That's the vertical asymptote. That's the x-intercept. The curve is positive. That means the curve is above x-axis. It looks like this. From pi to 3 pi over 2, that's the graph of cotangent. Next, from 3 pi over 2 to 2 pi. From 3 pi over 2 to 2 pi, sine function is negative. Cosine function is positive. Cotangent is cosine over sine. Positive number over negative number is negative. So that's the vertical asymptote. That's the x-intercept. The curve is below x-axis. It looks like this. That's the graph between 3 pi over 2 and 2 pi. Next, the graph between negative pi over 2 and 0. For the graph between negative pi over 2 and 0, sine function is negative. Cosine function is positive. Negative number, cotangent is cosine x divided by sine x, which is positive number divided by negative number. Positive number divided by negative number is negative. So between negative pi over 2 and 0, cotangent is negative. That's an x-intercept. That's the vertical asymptote. So the graph looks like this. Next, for the graph between negative pi and negative pi over 2, sine function is negative. Cosine function is also negative. Double negative is positive. Cotangent is cosine over sine. Negative number divided by negative number, double negative is positive. then that's the x-intercept, that's the vertical asymptote. The graph looks like this. So that's the graph of cotangent function. And same thing, there are infinitely many such pieces. There are infinitely many such pieces on both sides. That's the graph of cotangent functions. And for cotangent function, we can see that here. The domain is the set of all real numbers, except these vertical asymptotes. Vertical asymptote here at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. So s cannot be 0, it cannot be plus or minus pi, it cannot be plus or minus 2 pi, it cannot be plus or minus 3 pi, and so on. That's a domain. S cannot be 0, it cannot be plus minus pi, it cannot be plus minus 2 pi, and 3 pi, and so on. That's a domain. The range is the set of all real numbers from negative infinity to infinity. It goes for y, from the y value, it goes down to negative infinity and go up to positive infinity. The range is the set of all real numbers from negative infinity to infinity. And the period, same thing, the period from 0 to pi, the graph repeats itself. From pi to 2 pi, the same graph repeats itself. Similarly, from 2 pi to 3 pi, the same graph repeats itself. So the period for the cotangent function, the period is also pi. From 0 to pi, the distance is pi. So for cotangent function, the period is also pi. The vertical asymptotes is s equal to 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. Those are the vertical asymptotes. And for tangent function, I forget. The vertical asymptotes. For tangent function, the vertical asymptotes is s equal to pi over 2, 3 pi over 2, 5 pi over 2, and so on. S equal to plus or minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on. There are infinitely many vertical asymptotes. Those are the graph of tangent and cotangent functions. Next, let me show you the graph of the secant function. We know that secant of x can always be written as 1 over cosine x. That's one of the trig identities. So we'll graph secant function based on the graph of cosine. Here I'll graph secant function based on the graph of cosine. Let me first graph cosine. Cosine function looks like this. It starts from 1. Its first period is from 0 to 2 pi. That's pi. That's pi over 2. That's 3 pi over 2. And the same curve repeats itself. From 2 pi to 4 pi looks exactly the same. Three pi is here. Here is 5 pi over 2. 7 pi over 2 is here. And before 0, the same graph repeats itself. From 0 to 2 pi, it looks exactly the same. From 0 to negative 2 pi, it looks exactly the same. Negative pi is here. That's negative pi over 2. That's negative 3 pi over 2. This is the cosine function. This is the cosine function. Here I'll graph secant based on cosine. We know that secant is always 1 over cosine. At 0, cosine 0 is 1. Secant is 1 over cosine. 1 over 1 is 1. So secant of 0 is also 1. Since cosine 0 is 1, secant 0 is also 1. 1 over 1 is 1. How about pi over 2? Cosine pi over 2 is 0. Cosine pi over 2 is 0. Secant is 1 over cosine. 1 over 0 is undefined. So that's a vertical asymptote. When the numerator is not 0, the denominator is 0, we have a vertical asymptote. So secant pi over 2 is a vertical asymptote. Secant at pi over 2 is a vertical asymptote. How about pi? Cosine of pi is negative 1. Cosine of pi is negative 1. Secant is 1 over cosine. 1 over negative 1 is negative 1. 1 over negative 1 is negative 1. So secant at pi is negative 1. 1 over negative 1 is negative 1. Secant at pi is negative 1. How about 3 pi over 2? Cosine 3 pi over 2 is 0. Cosine 3 pi over 2 is 0. Secant is 1 over 0. 1 over 0 is 1. 1 over 0 is undefined. So that's a vertical asymptote at 3 pi over 2. That's a vertical asymptote at 3 pi over 2. And at 2 pi here. At 2 pi here. Cosine of 2 pi is 1. Cosine of 2 pi is 1. Secant is 1 over cosine. 1 over 1 is 1. So secant at 2 pi is 1. How about 5 pi over 2? Cosine 5 pi over 2 is 0. Cosine 5 pi over 2 is 0. 1 over 0 is undefined. So that's a vertical asymptote. On the other side, at negative pi over 2, at negative pi over 2, cosine negative pi over 2 is 0. 1 over 0 is undefined. That's a vertical asymptote. At negative pi, cosine negative pi is negative 1. 1 over negative 1 is negative 1. Secant at negative 1 is negative 1. Secant at negative pi is negative 1. How about negative 3 pi over 2? Cosine negative 3 pi over 2 is 0. Secant is 1 over cosine. 1 over 0 is undefined. So that's a vertical asymptote at negative 3 pi over 2. Now let's sketch a graph. Based on this, let's sketch a graph. Between 0 and pi over 2, cosine function is positive. 1 over a positive number is positive. So secant from 0 to pi over 2 is also positive. That's a point here. That's a point on the curve. That's the vertical asymptote. The curve is positive. It must be above. It must go above x-axis. It must get closer to an asymptote. It looks like this. That's a point on the curve. That's a vertical asymptote. and the curve is above x-axis. It looks like this. Next, from pi over 2 to pi, cosine function is negative. 1 over a negative number is negative. That's a vertical asymptote. That's a point on the curve. So the curve looks like, and the graph is below x-axis. It looks like this. The graph must get closer to the asymptote, to the vertical asymptote. From pi to 3 pi over 2, cosine function is negative. 1 over a negative number is negative. So that's a point on the curve. That's the vertical asymptote. The curve is below x-axis. It looks like this. The curve must get closer to the asymptote. The curve must get closer to the asymptote. Then here from 3 pi over 2 to 2 pi, cosine is positive. 1 over a positive number is positive. That's a point on the curve. That's a vertical asymptote. The curve is above x-axis. It looks like this. Next, from 2 pi to 5 pi over 2, cosine is positive. 1 over a positive number is positive. That's a point on the curve. That's the vertical asymptote. So the graph looks like this. Now on the other side, from 0 to negative pi over 2, cosine function is positive. 1 over a positive number is positive. So from 0 to negative pi over 2, secant is also positive. That's a point on the curve. That's a vertical asymptote, and the curve is above x-axis. It looks like this. Then, next, from negative pi over 2 to negative pi, cosine is negative. 1 over a negative number is negative. That's a point on the curve. That's a vertical asymptote, and the curve is below x-axis. It looks like this. Next, between negative pi and 3 pi over 2, cosine is negative. Secant is 1 over cosine. 1 over a negative number is negative. That's a point on the curve. That's a vertical asymptote, and the curve is below x-axis. It looks like this. So that's the graph of secant function. The graph repeats itself. Down, up, down, up, down, up, and down. Up, down, up, and down. Open up, open down. Open up, open down. Next, the same curve repeats itself. So we can see that here, the domain of secant function. The domain of secant function is all real numbers, except these vertical asymptotes. The vertical asymptote is pi over 2, 3 pi over 2, 5 pi over 2, and so on. So s cannot be plus or minus pi over 2, cannot be plus minus 3 pi over 2, it cannot be plus minus 5 pi over 2, and so on. S cannot be these vertical asymptotes. That's a domain. For the range, it starts from 1. It's from 1 to infinity. On the other side, start from negative 1. From negative 1 to negative infinity. So for the range, there are two pieces. From negative infinity to negative 1, including negative 1. And from 1 to infinity. That's a range. From 1 to infinity, or from -1 to -infinity. That's a range. Either from 1 to infinity or from -1 to -infinity. That's a range. And 1 and -1, they are included. The period for secant, it opens up and down, up and down. The same graph repeats itself. That's one period. From -π/2 to 3π/2, that's one period. And we know that this is pi. From -π/2 to π/2, that's pi. Half of pi, that's 1 pi. That's half of pi together, that's another pi. So the period of secant is 2 pi. The period of secant function is 2 pi. From -π/2 to 3π/2, that's 2 pi. That means it repeats itself every 2 pi. That's one period. From -π/2 to 3π/2, that's half of pi. There are 4 halves of pi. 4 halves of pi is 2 pi. So the period of secant function is 2 pi. The vertical asymptote is s equal to plus or minus pi/2, plus or minus 3π/2, plus minus 5π/2, and so on. Those are the vertical asymptotes of secant function. That's the domain, range, period, and vertical asymptotes. Next, let me show you the graph of cosecant function. We know that cosecant function can always be written as 1 over sine x. That's one of the trig identities. Cosecant x is always 1 over sine x. So I'll graph cosecant function based on the graph of sine function. Here I'll graph cosecant function based on the graph of sine function. Let me first of all graph sine function. Graph of sine function looks like this. It starts from 0. Its first period is from 0 to 2 pi. That's its first period. What's in the middle is pi. It reaches its maximum at pi/2. The maximum is 1. It reaches its minimum at 3π/2. Its minimum is -1. And the same graph repeats itself for every 2 pi. From 0 to 2 pi looks like this. From 2 pi to 4 pi looks exactly the same. What's in the middle is 3 pi. And the maximum here is 5π/2. The minimum here is 7π/2. And same thing, it repeats itself before 0. From 0 to -2 pi, the graph looks exactly the same. That's -pi, -π/2, -3π/2. That's the graph of sine function. That's the graph of sine function. Here I'll graph cosecant based on the sine function. Let me put a graph here. Sine function at 0 is 0. 1 over 0 is undefined, so there's a vertical asymptote at 0. For cosecant, there's a vertical asymptote at 0. At pi/2, sine pi/2 is 1. 1 over 1 is 1. So for cosecant, it's 1 at pi/2. At pi, sine pi is 0. 1 over 0 is undefined. So there's a vertical asymptote at pi. There's a vertical asymptote at pi. At 3 pi over 2, sine 3 pi over 2 is negative 1. 1 over negative 1 is negative 1. So cosecant at 3 pi over 2 is negative 1. Cosecant at 3 pi over 2 is negative 1. At 2 pi, sine 2 pi is 0. 1 over 0 is undefined. So there's a vertical asymptote at 2 pi. At 5 pi over 2, sine 5 pi over 2 is 1. 1 over 1 is 1. So cosecant is 1 at 5 pi over 2. Sine 3 pi is 0. 1 over 0 is undefined. So for cosecant, there's a vertical asymptote at 3 pi. On the other side, at negative pi over 2, sine negative pi over 2 is negative 1. 1 over negative 1 is negative 1. So at negative pi over 2, cosecant is negative 1. Sine negative pi is 0. Sine negative pi is 0. 1 over 0 is undefined. So there's a vertical asymptote at negative pi. Next, let's sketch the graph. We know that sine function from 0 to pi over 2 is positive. 1 over a positive number is positive. So cosecant from 0 to pi over 2 is positive. That's a vertical asymptote. That's a point on the curve. Since the curve is above x-axis, it looks like this. From pi over 2 to pi, sine function is positive. 1 over a positive number is positive. That's a vertical asymptote. That's a curve. That's a point on the curve. And since the curve is positive, it goes above x-axis. Next, from pi to 3 pi over 2, sine function is negative. 1 over a negative number is negative. 1 over a negative number is negative. That's a point on the curve. That's a vertical asymptote, and the curve is below x-axis. It looks like this. From 3 pi over 2 to 2 pi, sine function is negative. 1 over a negative number is negative. That's a point on the curve. That's a vertical asymptote, and the curve goes below x-axis. It looks like this. Next, from 2 pi to 5 pi over 2, sine function is positive. 1 over a positive number is positive. That's a point on the curve. That's a vertical asymptote, and the curve is above x-axis. It looks like this. From 5 pi to 3 pi, sine function is positive. 1 over a positive number is positive. That's a point on the curve. That's a vertical asymptote, and the curve is above x-axis. It looks like this. on the other side. From 0 to negative pi over 2, sine function is negative. 1 over a negative number is negative. So that's a point on the curve. That's the vertical asymptote. The curve is below x-axis. It looks like this. And from negative pi over 2 to negative pi, sine function is negative. 1 over a negative number is negative. That's a point on the curve. That's a vertical asymptote. And the curve is below x-axis. It looks like this. So that's the graph of cosecant function. That's the graph of cosecant function. It goes up and down, up and down, up and down. It repeats itself. Up and down, up and down. Repeat. There are infinitely many such pieces. And here we can see that the domain of the cosecant function for the domain of cosecant function, it could be all real numbers except these vertical asymptotes. The domain could be all real numbers except these vertical asymptotes. So all real numbers. S cannot be 0. S cannot be plus minus pi. S cannot be plus minus 2 pi. It cannot be plus minus 3 pi, and so on. That's a domain. It could be all real numbers except these vertical asymptotes. The range is from 1 to infinity, or from -1 to negative infinity. It's from -1, negative infinity to -1, or from 1 to infinity. The range is either from 1 to infinity or from -1 to negative infinity. Either from 1 to infinity or from -1 to negative infinity. So that's the range. From negative infinity to -1 or from 1 to infinity. And the period from 0 to 2 pi. The graph repeats itself for every from 0 to 2 pi. Goes up and down. That's one period. Next period from 2 pi to 4 pi, it goes up and down. And from 0 to negative 2 pi, it goes up and down. The period of cosecant function is 2 pi. It repeats itself every 2 pi. Up and down, that's one period. It goes up and down, that's one period. From 2 pi to 4 pi, it goes another up and down, that's another period. And the vertical asymptote here is s equal to 0, s equal to plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. There are infinitely many vertical asymptotes. That's the graph of cosecant. That's the graph of cosecant. That's its domain, range, period, and vertical asymptote. Next, let me show you some examples. Graph each of the following functions. First example, y equal to 2 sine x. How can we graph this function? In order to graph this function, let's choose the parent function first. For the parent function here, I will choose y equal to sine x. The graph of sine x in the first period looks like this. It starts from 0. The first period is from 0 to 2 pi. What's in the middle is pi. Upper bound is 1, and lower bound is -1. That's graph of sine x in the first period. Now, when we multiply the function by 2, we stretch the graph vertically by a factor of 2. So, for y equal to 2 sine x, stretch the graph vertically by a factor of 2. Stretch the graph vertically by a factor of 2. We get a function y equal to 2 sine x. If I stretch the graph vertically, the maximum was 1, now it becomes 2. Minimum was -1, now it becomes -2. The intercept stays the same. That's the graph y equal to 2 sine x. That's the graph y equal to 2 sine x. And we know that the graph sine curve repeats itself every 2 pi. The curve continues. That's the graph y equal to 2 sine x. For this graph, the amplitude is 2. Period stays as 2 pi. For this graph, amplitude is 2. Amplitude is the half of the distance from the maximum to minimum. From negative 2 to 2. That's the distance from maximum to minimum. Half of the distance is from 0 to 2. So the amplitude is 2. Next example. How can we graph the function y equal to -3 cosine x? How can we graph the function y equal to -3 times cosine x? First step, let's choose the parent function. Here, for the parent function, I choose y equal to cosine of x. Let's first of all graph cosine of x in the first period. The graph of cosine x in the first period is start from 1. It goes down first, then goes back to 1. That's the first period of cosine, from 0 to 2 pi. Also in the middle is pi. And the intersection is the midpoint between 0 and pi. That's pi over 2. The other intersection is the midpoint between pi and 2 pi. That's 3 pi over 2. That's the graph of cosine function in the first period. Next, let's multiply the function by 3 first, and then I'll take care of negative sign. If I multiply the function by 3, I stretch the function vertically by a factor of 3. Stretch the graph vertically by a factor of 3. Stretch the graph vertically by a factor of 3. I get a function y equal to 3 cosine x. Stretch the graph vertically by a factor of 3. The maximum was 1 here. If I stretch it by a factor of 3, it becomes 3. 1 becomes 3 here. Lower bound was -1. Now if I stretch it by a factor of 3, it becomes -3. The rest stays the same. That's the graph of y equal to 3 cosine x. Next, I multiply the function by -1. If I multiply the function by -1, I flip the graph over the x-axis. If I multiply the function by -1, I flip the graph over the x-axis. If I flip the graph over the x-axis, I get y equal to -3 cosine x. Let me flip it over. If I flip it over, -3 and +3 stays the same. But at this point, it was +3 here. If I flip over x-axis, it becomes -3. So I start from here. This point is -3. If I flip over, it becomes +3. This point was +3. If I flip over, it becomes -3. That's 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's a graph of the function y equal to -3 cosine x. And we know that sine and cosine function repeats itself. So actually the curve continues. The curve actually continues on both directions. The curve actually continues on both directions. That's the graph of the function. And for this function, amplitude is 3. Amplitude is half of the distance from maximum to minimum. Here, distance from maximum to minimum is from -3 to 3. Half of the distance is from 0 to 3. So amplitude here is 3. From -3 to 3, the distance is 6. Half of the distance is 3. And the period here, period is from 0 to 2 pi. The period is 2 pi. For this function, the period is 2 pi. Next example, y equal to 4 cosine of 2x. In order to graph this function, let's first of all choose the parent function. For this function, we choose y equal to cosine of x to be the parent function. Let's graph this function in the first period. Let's graph this function in the first period. For cosine function, it starts from 1. The first period is from 0 to 2 pi. It looks like this. It goes down first, then bounce back. At 2 pi, it goes back to 1. At 2 pi, it goes back to 1. What's in the middle is pi. Intersection here is pi over 2 and 3 pi over 2. That's the cosine function in the first period. That's the cosine function in the first period. Next, when we multiply the function by 4, we stretch the graph vertically by a factor of 4. So we first of all stretch the graph vertically by a factor of 4. For y equal to 4 cosine of x. Stretch the graph vertically by a factor of 4. If I stretch the graph vertically by a factor of 4, this point 1 here becomes 4. the minimum is -1. If I stretch it vertically, -1 becomes -4. And everything else stays the same. That's pi over 2. That's pi. 3 pi over 2. And that's 2 pi here. That's 0. That's the graph y equal to 4 cosine of x. Next, if I multiply x by 2, I shrink the graph horizontally by a factor of 1 over 2. If I multiply x by 2, I shrink the graph horizontally by a factor of 1 over 2. Next, shrink the graph horizontally by a factor of 1 over 2. If I multiply the function by 2, if I multiply x by 2, I shrink the graph horizontally by a factor of 1 over 2. Next, shrink the graph horizontally. For y equal to 4 cosine of 2x, shrink the graph horizontally by a factor of 1 over 2. So -4 and 4 stays the same. Shrink the graph horizontally by a factor of 2. If I shrink the graph horizontally by half, 2 pi times half is pi. This pi times half is pi over 2. Pi over 2 times half is pi over 4. 3 pi over 2 times half is 3 pi over 4. Shrink the graph horizontally by a factor of 4, by a factor of 1 over 2. And the graph looks like this. Shrink the graph horizontally by a factor of 1 over 2. That's how it looks like. And based on this graph, we can see that the amplitude of this function is 4. Amplitude is the half of distance from maximum to minimum. Distance from maximum to minimum is from -4 to 4, which is a. Half of the distance is 4. So amplitude is 4. What's the period? Here, the graph repeats itself from 0 to pi. So for this function, its period is pi. The graph repeats itself from 0 to pi, which is pi. So period is pi. And also we know that the graph continues after pi. The graph continues on both directions. That's the graph of this function, y equal to 4 cosine of 2x. Actually, the graph continues itself. The graph continues on both directions. It keeps going up and down, up and down, up and down. Next example. How can we graph the function y equal to 1 over 2 times sine of 1 over 3x? How can we graph the function 1 over 2 times sine of 1/3 of x? In order to graph this function, let's first of all choose the parent function. Here we can choose the parent function to be y equal to sine x. So let's first of all graph sine x in the first period. Sine x in the first period is from 0 to 2 pi. It starts from 0. That's sine x in the first period. What's in the middle is pi. pi over 2, the curve reaches its maximum at 1. At 3 pi over 2, the curve reaches its minimum, which is -1. That's the graph of sine x. That's the graph of sine x in the first period. Next, let's graph this function. If I multiply sine by a half, if I multiply the entire function by half, I shrink the graph vertically by a factor of half. If I multiply the function by half, if I multiply the entire function by half, shrink the function vertically by a factor of half. Shrink the graph vertically by a factor of half. So the function is y equal to half of sine x. If I multiply the function by half, shrink the graph vertically by a factor of half. So the maximum, it was 1. If I shrink it by half, if I shrink it vertically by half, the maximum becomes half. The minimum was -1. If I shrink the graph vertically by half, minimum becomes -half. And the rest stays the same. The graph stays the same, start from 0. That's 0, that's pi, that's 2 pi. That's the graph of half of sine x. Next, if I multiply x by a third, reciprocal of 1/3 is 3, so we stretch the graph horizontally. Stretch the graph horizontally by a factor of 3. Next, for y equal to half of sine of 3x, for half of sine of 1/3 of x, if I multiply x by a third, I stretch the graph horizontally by a factor of 3. Stretch the graph horizontally by a factor of 3. When I stretch the graph, the upper bound and lower bound stays the same. When we stretch the graph horizontally, upper bound and lower bound stays the same. If I stretch the graph horizontally by 3, 2 pi becomes 6 pi, and this pi becomes 3 pi. If I stretch the graph horizontally, 2 pi becomes 6 pi. This pi itself becomes 3 pi. If I stretch the graph horizontally by a factor of 3, and the maximum minimum stays the same. That's the graph y equal to half of sine of 1/3 of x. And based on this graph, we can tell that the amplitude of this graph is half. Amplitude is half of the distance from maximum to minimum. Here, distance from maximum to minimum, half plus half is 1. Half of the distance is half. And the period of this graph is from 0 to 6 pi. From 0 to 6 pi, the graph starts complete one period. The period of this graph is 6 pi. From 0 to 6 pi, it completes one period. And then we know that the graph repeats itself after 6 pi. the graph continues on both directions. That's the graph of the function y equal to half of sine of 1/3 of x. Next example, y equal to sine of half of x plus 2. How can we graph this function? In order to graph this function, let's first of all choose the parent function. For this function, its parent function, I can choose y equal to sine x. Let's first of all graph its parent function in the first period. Sine function in the first period is from 0 to 2 pi. It starts from 0. What's in the middle is pi. And at pi over 2, the graph reached the maximum at 1. At 3 pi over 2, the graph reaches its minimum at -1. That's the parent function. Next, based on its parent function, we try to graph this function y equal to sine of half of x plus 2. If I multiply x by half, the reciprocal of half is 2. That means I stretch the graph horizontally by a factor of 2. Reciprocal of half is 2. I stretch the graph horizontally by a factor of 2. Stretch the graph horizontally by a factor of 2. I get y equal to sine of half of x. Stretch the graph horizontally by a factor of 2. If I stretch the graph horizontally, the maximum and minimum stays the same. Stretch the graph horizontally by a factor of 2. So 2 pi become 4 pi. Pi in the middle become 2 pi. Pi over 2 times 2 is pi. 3 pi over 2 times 2 is 3 pi. The graph looks like this. Here we stretch the graph horizontally by a factor of 2. Next, when I add 2 to the function, I shift the graph up by 2 units. When I add 2 to the function, I shift the graph up by 2 units. So shift 2 units upward. The function is y equal to sine of half of x plus 2. Shift this graph up by 2 units. The maximum is 1. The maximum of the graph is 1. If I shift up by 2 units, it becomes 3. The minimum is -1. If I shift it up by 2 units, it becomes 1. So that's the maximum, that's the minimum. 0, pi, 2 pi, 3 pi, 4 pi stays the same on the x-axis. The period stays the same. We shift the graph up by 2 units. So this point is 0. If I shift 0 up by 2 units, it becomes 2. I start from 2. Draw the graph in the same shape. Here I shift this graph up by 2 units. That's the graph of y equal to sine of half of x plus 2. And based on this graph, we can tell that the amplitude The amplitude of the graph is the half of the distance from maximum to minimum. That's the maximum, that's the minimum. Distance from maximum to minimum is 2. From 3 to 1, distance is 2. Half of the distance is 1. So amplitude is 1. The period of the graph is 4 pi. Period of the graph is 4 pi. Because the graph repeats itself every 4 pi. The graph repeats itself every 4 pi. Period of the graph is 4 pi. And the curve continues in both directions. The curve continues on both directions. That's the first period from 0 to 4 pi. And the curve continues itself on both directions. Next example. Y equal to 2 cosine of x minus 1. Y equal to 2 cosine of x minus 1. How can we graph this function? In order to graph this function, let's first of all choose the parent function. Here we choose y equal to cosine x as the parent function. Here we choose y equal to cosine of x as the parent function. Let's first of all graph cosine x in the first period. For cosine x in the first period, it starts from 1. It goes down first. Then it bounces back. Go up to 1 at 2 pi. Maximum is 1. And the minimum here is negative 1. What's in the middle is pi. The intersection here is pi over 2. And 3 pi over 2. That's the cosine function in the first period. Next, if I multiply the function by 2, we stretch the graph horizontal. We stretch the graph vertically by a factor of 2. Next, stretch the graph vertically by a factor of 2. Stretch the graph vertically by a factor of 2. We have y equal to 2 cosine of x. Maximum here is 1. If I stretch the graph vertically by 2, 1 becomes 2. Minimum is negative 1. If we stretch the graph vertically by 2, negative 1 becomes negative 2. Everything else stays the same. Graph stays the same shape. 0, pi over 2, pi, 3 pi over 2, and 2 pi. The graph stays the same shape. That's the graph y equal to 2 cosine of x. Next, if I subtract 1 from the function, I shift the entire graph 1 unit downward. Shift the entire graph 1 unit downward. Next, shift the entire graph 1 unit downward. I get y equal to 2 cosine of x minus 1. Shift the entire graph 1 unit downward. If I shift the graph downward by 1 unit, number 2 becomes 1. 0. This 0 here becomes negative 1. Negative 2 here becomes negative 3. So the graph stays the same shape. That's pi over 2 here. That's pi. That's 3 pi over 2. And that's 2 pi. That's the graph in the first period. That's the graph in the first period. Based on this graph, we can tell the amplitude is half of the distance from maximum to minimum. Here, the distance from maximum to minimum is from -3 to 1, which is 4. And half of the distance is 2. That's the amplitude. The period is from 0 to 2 pi. From 0 to 2 pi, the graph completes one period. So the period of this graph is from 0 to 2 pi, which is 2 pi. And we know that for sine and cosine function, the graph repeats itself every 2 pi. So the graph continues. The graph continues on both directions. That's the graph of this function. Next example. How can we graph the function y equal to 3 times sine of x minus pi over 4? In order to graph this function, let's first of all choose the parent function. For the parent function, I choose y equal to sine x. Next, let's graph sine x in the first period. Sine x in the first period starts from 0. The intersection is pi and 2 pi. Maximum is 1, and the minimum is -1. That's the graph of sine x in the first period. Next, if I multiply the function by 3, we stretch the graph vertically by a factor of 3. If I multiply the entire function by 3, we stretch the graph vertically by a factor of 3. Stretch the graph vertically by a factor of 3. I get y equal to 3 sine x. Its graph looks like this. Maximum, minimum become -3 and +3. Everything else stays the same. The graph stays in the same shape. That's the graph y equal to 3 sine x. Next, if I subtract x by pi over 4, I shift the graph pi over 4 units to the right. If I subtract x by pi over 4, I shift the graph pi over 4 units to the right. Next, shift the graph pi over 4 units to the right. Shift the graph pi over 4 units to the right. I get y equal to 3 times sine of x minus pi over 4. Shift the graph pi over 4 units to the right. If I shift the graph to the left or right, maximum minimum stays the same. The maximum and the minimum stays the same. Shift the graph pi over 4 units to the right. 0 plus pi over 4 is pi over 4. Pi plus pi over 4 is 5 pi over 4. Two pi plus pi over 4 is 9 pi over 4. That's the graph. And based on this graph, its amplitude is 3. Amplitude is half of the distance from maximum to minimum. Distance from maximum to minimum here is 6. So half of the distance is 3. What's the period? What's the period here? Here, the first period is from pi over 4 to 9 pi over 4. Here, the first period is from pi over 4 to 9 pi over 4. 9 pi over 4 minus pi over 4. If I subtract 9 pi over 4 minus pi over 4 is 8 pi over 4. 8 pi over 4 is the same as 2 pi. Here, amplitude is 3. Period is 2 pi. And we know that the graph repeats itself every 2 pi. The graph repeats itself every 2 pi. Next example. How can we graph the function y equal to negative cosine of x plus pi over 2? How can we graph the function y equal to negative cosine of x plus pi over 2? Let's first of all choose a parent function. Here, for this function, I choose y equal to cosine of x as the parent function. Next, let's graph cosine of x in the first period. Cosine of x starts from 1. It goes down first, then it goes back to 1. It goes back to 1. It goes back to 1 at 2 pi. We have pi in the middle, pi over 2, and 3 pi over 2 as an intersection. Maximum is 1, minimum is negative 1. That's the graph of cosine of x in the first period. Next, if I make the function negative, I flip the graph over the x-axis. If I make the function negative, I flip the graph over the x-axis. Flip the graph over the x-axis. If I flip the graph over, positive 1 become negative 1, and negative 1 become positive 1. If I flip the graph over x-axis, positive 1 become negative 1, and negative 1 become positive 1. Everything else stays the same. So I start from negative 1. If I flip over, positive 1 become negative 1. Now for this cosine function, I start from -1. -1 become +1. And +1 become -1. That's y equal to negative cosine of x. Next, if I add pi/2 to x, I shift the graph pi/2 units to the left. Next, if I add pi/2 to x, I shift the graph pi/2 unit to the left. If I add pi/2 to x, I shift the graph pi/2 units to the left. Shift the graph pi/2 units to the left. If I shift the graph left and right, maximum minimum stays the same. Shift the graph pi/2 unit to the left. So 0 become negative pi/2. Pi/2 becomes 0. Pi become pi/2. 3 pi/2 become pi. And 2 pi becomes 3 pi/2. Subtract each number by pi/2. If I shift the entire graph pi/2 to the left, subtract each number by pi/2. I get this. Next, sketch the graph in the same shape. That's the graph in the first period. Based on this graph, we can tell that the amplitude of the graph is 1. Amplitude is half of the distance from maximum to minimum. Here, maximum is 1, minimum is -1. Distance from maximum to minimum is 2, and half of the distance is 1. What's the period here? Here, the first period is from negative pi/2 to 3 pi/2. 3 pi/2 minus negative pi/2 is 3 pi/2 plus pi/2, which is 2 pi. 3 pi/2 minus negative pi/2 is 3 pi/2 plus pi/2, which is 4 pi/2, which is 2 pi. So the period of this graph is 2 pi. That's the first period. And we know that the graph repeats itself. So the graph continues on both sides. The graph continues on both sides. That's the graph of this function. Next example. How can we graph the function y equal to tangent of half of x? Let's choose the parent function first. For tangent of half of x, I choose the parent function to be tangent of x. The graph of tangent x looks like this. Its first period is from negative pi/2 to pi/2. Second period is from pi/2 to 3 pi/2. Intersection here is pi. On the other side, another period here is negative 3 pi/2. Intersection in the middle is negative pi. The graph of tangent looks like this. There are infinitely many such pieces. There are infinitely many such pieces. That's the graph of tangent x. Now, if I multiply x by half, reciprocal of half is 2. That means I stretch the graph horizontally by a factor of 2. Stretch the graph horizontally by a factor of 2. Stretch the graph horizontally by a factor of 2. For y equal to half of x, the graph looks like this. I stretch this graph horizontally by a factor of 2. If I stretch the graph horizontally, pi over 2 times 2 is pi. Pi times 2 becomes 2 pi. 3 pi over 2 times 2 is 3 pi. On the other side, negative pi over 2 times 2 is negative pi. Negative pi times 2 is negative 2 pi. Negative 3 pi over 2 times 2 is negative 3 pi. Those are the vertical asymptotes. And the graph stays the same shape. The graph stays the same shape. There are infinitely many such pieces. And for tangent function, there are no amplitudes. We have a period. The period was pi. But if I stretch the graph horizontally by 2, period becomes 2 pi. Originally, period was pi. If I stretch the graph horizontally by a factor of 2, the period becomes 2 pi. The period was pi. Originally, for tangent function, its period was pi. If I stretch the graph horizontally by 2, 2 pi become 2 pi. That's the period of this graph. For tangent function, there's no amplitude. That's the period, 2 pi. It was pi, but if I stretch the graph horizontally by 2, pi becomes 2 pi. That's the period of this graph. Next example. How can we graph the function y equal to 2 times secant of 3x? How can we graph the function y equal to 2 times secant of 3x? Let's first of all choose the parent function. Here I can choose y equal to secant of x. Let secant of x be the parent function. Its graph looks like this. Pi is here. 3 pi over 2 is here. 2 pi is here, 5 pi over 2 is here. On the other side, negative pi is here, negative 3 pi over 2 is here. The graph always goes up and down, up and down, up and down. That's the graph, that's the pattern function, y equal to secant of x. Next, if I multiply the function by 2, I stretch the graph vertically by a factor of 2. If I multiply the function by 2, I stretch the graph vertically by a factor of 2. So 1 become 2. If I stretch vertically, number 1 become 2. Negative 1 become negative 2. So for all pieces, the minimum become 2. Maximum become negative 2. The new function is y equal to 2 secant x. And its graph looks like this. The minimum is 2. If I stretch vertically, 1 become 2. And the maximum become negative 2. That's how the graph looks like when we multiply secant by 2. Next, if I multiply x by 3, we know that reciprocal of 3 is 1/3. So we shrink the graph horizontally. By a factor of 1/3. This reciprocal of 3 is 1/3. When I multiply 3 to x, I shrink the graph horizontally by a factor of 1/3. Next, shrink the graph horizontally by a factor of 1/3. Next, shrink the graph horizontally by a factor of 1/3. That's the graph of the function y equal to 2 secant of 3x. I shrink the graph by horizontally by a factor of 1/3. So pi over 2 times 1/3 become pi over 6. And negative pi over 2 become negative pi over 6. Next, pi times 1/3 is pi over 3. Negative pi becomes negative pi over 3. Next, 3 pi over 2 times 1/3 become pi over 2. 3 pi over 2 times 1/3 become pi over 2. So you see negative 3 pi over 2 become negative pi over 2. Next, 2 pi times 1/3 is 2 pi over 3. Next, 5 pi over 2 times 1/3 is 5 pi over 6. And the graph stays in the same shape. Here, minimum is 2. Each maximum is negative 2. The graph stays in the same shape. For secant and cosecant, it always goes up and down, up and down. Its graph always goes up and down, up and down. That's the graph of a function, y equal to 2 secant of 3x. And for secant and cosecant, there's no amplitude. What's its period? For secant function, its period it was 2 pi originally. It was 2 pi. For secant function, its period was 2 pi. But since I shrink the graph horizontally by 1/3, I take 2 pi times 1/3 is 2 pi over 3. That's the period of this function. For secant function, its period it was 2 pi originally. It was 2 pi. But since I shrink the graph horizontally by 1/3, I take 2 pi times 1/3, which is 2 pi over 3. That's the period of this secant function. For tangent, cotangent, secant, cosecant, there are no amplitudes. So that's the graph of this function.